January the 17th, 2017. Guys, I want to show you a quick video from NASA concerning heliophysics, or the science of the sun. And it has to do with many of the subjects that we've been talking about. Solar minimum, many ice ages, the shields of the Earth weakening, and gamma radiation coming from not the sun, but from external sources, cosmic radiation. But as we go into solar maximums, and we see the input from the sun coming towards our planet as far as solar wind, coronal mass ejection, solar flares, that energy is transferred into the core of the Earth via the magnetic shields, these magnetic field lines that are the magnetosphere that surrounds our planet. That's why we're seeing the deeper quakes. When you go at 650 kilometers depth, you're into what's called the magma transition zone. That's deep. But as we see increased solar activity, and represented here is coming from the left, then the magnetopause responds and strengthens our shield. As you see this go through the bow shock, and then you go through the actual magnetopause itself, then we have strong shields. But when we go through a solar minimum, the Earth shields are weaker, and external radiation comes in. So we lose protection. And these magnetic lines that you see going around the planet feed energy. These are charged particles. Check this out, feeding down into the core. Again, magma, earthquakes, volcanoes, the plasmasphere. That will extend very far towards the sun during these events and increase the strength of our shields. When it does that, guys, it's blocking the external gamma radiation, right? You understand what I'm saying? Now, why is it so important? We'll go through that. Just pay attention. You've got ring current. This increases. This is part of our shields. But when that happens, it increases the Van Allen radiation belt. You see here, it's always shown 2. But guys, in 2012, satellites were picking up during extreme solar activity a 3rd radiation belt. Check this out. 2012 observations from the Van Allen probe showed the 3rd belt can sometimes appear. And what that does is create a whole new science in itself. As the Earth shields absorb this incoming radiation, it creates the radiation belts. That's where the Van Allen radiation belt comes from. So as we get more and more energy coming in, it creates a 3rd belt as a 3rd buffer zone to try to absorb some of this energy. During that time, we do have increased radiation belts surrounding the planet, but our Earth shields are very strong. That's important. Now, think about that. Science changes all the time, but through the radiation belts also that we're showing here, only 2 in this particular video, as these orange and purple lines go through that high energy particles are transferred back and forth, heating the Earth's core. Now, this gets right down to it, guys. Notice the timestamp at the bottom, 2015. The next bar is 2016. At the top, it's showing the solar cycles. This one started around 2009, called Solar Cycle 24. It was one of the smaller ones. Check it out. I've got the red arrow drawn across going back to Cycle 21. And this chart starts around 1955, Cycle 19. Solar Cycle 24, very small. The bottom chart shows that during the solar minimums, in counts per hour, and this is coming from Greenland, that the neutron monitors, this is external cosmic radiation, not the sun, but particles that are allowed to penetrate during solar minimums, increases. So as you see the dips in the solar cycle at the top, you see increases in the radiation. Now, since Cycle 24, guys, is so small, and you see the last rise in the bottom chart around 2010 of the external cosmic radiation coming in, imagine what we're about to go through now. And we're going into 2017, and we have current information on this too. If you go to some of the ground-based radiation monitors, which is very important because that's what we deal with here. And this is Greenland. Now, what it's showing is counts per hour, and this is cosmic radiation, external, not from the sun. And in the 10 days, it's showing a 3% increase that starts January the 8th through January the 18th. Now, in Greenland, we're in winter. So you're going to have a lower count than you do on the South Pole. And we're going to look at the South Pole because they're in summer, so you have an increased exposure. But look at this array of 10-day panels. Starts over here at Nain, but if you go to the top left, you're starting in Canada, you're going through Greenland, Fort Smith, but the two bottom ones, South Pole on the right and McMurdo, both South Pole radiation data indicators, all are showing 3% increases around the planet, regardless of the count. Now, why is McMurdo in the bottom center not showing anything? It's because it's off scale. Notice the scale stops at 10,050 on McMurdo. Now, over on the South Pole, which is its sister information center, is starting at 11. But if you look at the current information, this is real-time data, nothing showing as of 10,050 as far as counts per hour. But notice at the bottom 6-month chart, and the reason is I'm going to go back and show you its sister station, the South Pole data, and you'll see why. Again, notice the top of the scale, 10,050. Let's go to South Pole. That it's because its sister station is well above its scale. Notice where it starts at 11,300, well above the 10,050. That's why McMurdo looks like it's not showing anything. It's well above its scale, and it should be adjusted. But look at these peaks going into midnight tonight, universal time, at over 11,750 counts per hour. 3% increase, again, at the bottom of the scale. But that's why McMurdo is not showing this. Why is this important? It's because of what this external cosmic radiation can do to you. Do you know that one particle can change your DNA structure in your reproductive system and cause mutation? Now that brings about a very important question. If this increased gamma radiation, and we're looking at the stratospheric radiation for 1 year, showing over California 12.4% increase. Now that's not ground-based, that's just stratospheric radiation, and this is from balloons going up into the atmosphere, and that's what they're seeing in the upper atmosphere. 12.4% in 1 year. And what the charts you were looking at again were ground-based. Why is it important? It says that organizations involved in very high altitude flying are interested in their pilots' exposure to radiation. A single cosmic ray particle can change a computer memory cell or change a chromosome in a reproductive cell. It can affect radio communications, corrosion in pipelines, things like that. But guys, chromosome in a reproductive cell, and translate that to genetic mutation in your offspring. And what does that mean? Does it mean that we're being changed naturally or mutated so that future generations can be able to absorb this radiation? Or is it something we cannot deal with at all? Is it the grievous sore? Is it melanoma? We don't know, guys, but one thing that we do know is this is also involved in solar minimum and the mini ice age. Now, in this report, it says, do cosmic rays affect Earth's weather and climate? Now, remember, cosmic rays are not solar rays. They're two different things. Cosmic rays are external. Scientists are working to answer the questions and to understand how solar activity and cosmic rays might affect conditions on Earth's surface. There was a period between the years 1645 and 1715 called the moderate minimum, when there was little solar activity and few sunspots. During the same time, a period called the Little Ice Age, when temperatures became cooler in North America and Europe, occurred. Now look at this chart. Now you've got to remember what we're dealing with. This is showing sunspot numbers, solar minimum, mini ice age. During that time, There were volcanoes with ash that multiplied the effect. So let's go back to the first chart. We're going into solar minimum, top, coming out of cycle 24. Gamma radiation could spike at this period well above what we're used to. That energy feeds into the core of the earth and creates problems with deep earthquakes and magma movement into volcanoes and creates crustal problems. So you have volcanoes popping off during this solar minimum that we're going through. That deflects more sunlight and makes it even colder. But guys, I tried to answer as many questions as I can about this, but if you see these new 10-day charts with these 3% increases in 10 days, guys, that's alarming. I'm going to keep an eye on it. We'll update it. It's a heads up. Be safe.